Hi, I'm Carlos Campos with Cisco, and this time I brought a friend with me.
Hello everybody, my name is Germán Gonzalez and I'm a solutions architect working for AWS. Cloud migrations and disaster recovery are two of the most important topics that customers are interested in when beginning their journey to the cloud.
Exactly, Germán.
Today, we'll show you how to perform disaster recovery as a service using Cisco ACI and AWS. As you probably know by now, Cisco ACI allows you to centralize operations and provides consistent security policies for all types of networks, including clouds like AWS and Azure. This not only facilitates faster cloud onboarding, but it also allows you to have a single way to learning how to configure the network with ACI, which normalizes your network configuration into the corresponding cloud-native constructs. And it also provides an automated way for you to interconnect multiple clouds and even on-prem ACI networks using VXlan. This has proven to be very successful for cloud migration, cloud integration, disaster recovery as a service, and even cloud-only deployments when multiple clouds are used.
Right, Carlos. However, it is not only about the network. When migrating to the cloud, companies most commonly need to bring their data with them in order to make such migration as seamless as possible. This is where CloudEndure comes into play. CloudEndure is an AWS agent-based solution that can help you migrate bare metal servers or virtual machines to the cloud through its migration version. Not only does it support the most popular operating systems such as Windows and Linux, but it is also provided at no cost when moving workloads to AWS. Now, if we are talking about disaster recovery, CloudEndure also provides a DR version that supports failover and failback scenarios as well as other advanced functionalities. With that being said, you may want to migrate or increase the resiliency of your applications and workloads. This may be either DNS-based, like most of them out there, or IP-based exclusively in the case of legacy applications.
Right, Germán. So, if you have DNS-based applications running either on Windows or Linux like we do, the disaster recovery as a service process is very straightforward. In our case, our application is running in San Jose, California, and the CIO wants to reduce OpEx, especially after COVID, by trying disaster recovery as a service on AWS. We have already installed Cloud ACI on AWS, and we have implemented ACI multi-site orchestrator in order to connect both of them automatically, while centralizing operations and policy definitions. We have also installed CloudEndure agents in our Windows and Linux web servers running on-prem on VMware, so that the contents of each server are continuously replicated from San Jose to AWS. Now, this is a DNS-based application. Therefore, the DNS service, which in this case is running on AWS with Route 53, will translate each request made to the URL to the corresponding IP. With this being said, it really doesn't matter if you have different subnets on-prem and in the cloud. If the main site fails, Route 53 will automatically fail over to the IP on AWS, making it transparent to the user. Therefore, when apps are DNS-based, there is no need for you to stretch your on-premises subnet all the way to the cloud.
Right, Carlos. If you happen to have legacy applications that are IP-based only, this could be the right moment to change the code to use DNS or even modernize the application's architecture. Stretching subnets may cause multiple issues, including suboptimal routing and traffic tromboning when the gateway for such stretched subnet is still on premises. Therefore, we recommend our customers to avoid subnet stretching if possible. However, if you have no other way around it, we will show you in this demo how you can perform a disaster recovery for both DNS-based and IP-based environments, preserving the same IP for the instances only when needed by using ACI and CloudEndure.
Right, Germán. But before we go to the demo, let's first cover the differences for disaster recovery as a service, now with an IP-only environment, as we have both options in our demo. Our web servers have two virtual NICs. One with a public IP, which translates to the DNS server entry, as you saw before, and another one with a private IP and no DNS resolution. What we will also see in the demo for the private IP site is that as we fail over from San Jose to AWS, we will also be migrating the private subnet along with the servers, and due to the automatic VXlan extension provided by ACI and MSO, users will still seamlessly access to the same IP, just like if the web servers were still running on-prem. For those of you that are wondering about the configuration of this environment, let's now double-click on our ACI EPG layout. Our users are currently in the 10.100/24 network, and they are accessing the web servers which are in the 10.200/24 subnet, using their private IP site with no DNS resolution. As we said, those servers also have a public IP with DNS resolution, which in this case is being serviced by Route 53 on AWS. If we take a look inside Route 53 setup, we can see that we currently have both URLs mapped for our Windows and Linux machines. We have configured two different mappings for each one of them. The first one, which is marked as primary, is pointing out to the public IP on the on-premises side, which is in the 64.100.16 subnet. This is how our users are currently accessing the web servers when using DNS through Route 53. The second entry is marked as secondary, and it is mapped to an elastic IP within AWS. This means that Route 53 is constantly checking the on-prem web servers through some pre-configured health checks, and if they fail, the service will fail over to the secondary mapping automatically. At this point, we're only running on-prem, and that's why you can see that the health checks are in green only for the on-prem public IPs, and in red for the AWS elastic IPs. Once we fail over, you should see exactly the opposite, since we will be using those elastic IPs for the replicated instances. This is making it easier for us as admins, as no DNS remapping will be needed. All connectivity has been configured and provisioned by ACI Multi-Site Orchestrator, including the AWS network, which has been provisioned with the same 10.200.0.0/24 subnet in the US 1A availability zone within AWS. As mentioned, we are replicating all the web servers data through CloudEndure to AWS. With this being said, we now have the network and replication services configured once, and they are ready to be used anywhere.
Right, Carlos. As you said, CloudEndure is continuously replicating the data to EVS volumes on AWS. This way, whenever a failure is detected, CloudEndure will use those EVS volumes to create new EC2 instances automatically.
Exactly. Let's now take a look at the demo and see all this in action. If you remember, we currently have two web servers running on Linux and Windows. In this case, with a private 10.200.0.0/24 IP address. So far, users can ping both Linux and Windows servers successfully, as you can see. Both servers are running on top of VMware and belong to the web server CPG within the San Jose ACI site. This APIC is linked to a multi-site orchestrator where we have San Jose, Miami, and AWS APICs managed centrally. The whole network configuration has already been provisioned for all three sites centrally through MSO in the production schema, which includes the web server EPG. In the on-prem configuration, we have defined a bridge domain with the 10.200.0.1/24 subnet serving as the Anycast gateway for the web server CPG. And in the cloud, we have also defined the same subnet as part of our main CIDR configuration. Currently, both servers are being continuously replicated to the cloud using CloudEndure, which is an agent-based AWS replication service. And if we take a look at the replication blueprint inside CloudEndure console for the whole project, we have automatically identified which AWS instance type to use for each server once failover occurs, since through the agent we already know how much CPU, memory, and disk we will need once migrated to the cloud or as part of the failover process.
I'd also like to note that the CloudEndure agent installation process is extremely simple, Carlos. Just a few clicks and you will be replicating your Windows or Linux VMs or bare metal servers to AWS.
Right, Herman. If we go back to the blueprint now, we have also defined which subnet to use in the cloud, which in this case is the web server CPG, which was configured originally through MSO. The key part here is that we can instruct CloudEndure to maintain the same IP address or even hard-code it so that we can preserve it once migrated. As part of the blueprint, we have also specified which elastic IP to use, in order for us to demonstrate the automatic failover functionality from Route 53 for the DNS-based traffic. If we go to the AWS console, we can verify that there are no instances, except for the CloudEndure replicator, created at this point. Let's now simulate a failure on both servers by disconnecting both adapters on vCenter. You can see that we have immediately lost communication from the user's perspective. Let's now initiate failover to AWS on CloudEndure, and then let's go to the MSO in order to remove the web server subnet from the on-prem bridge domain configuration. This is done so that we can migrate that subnet to AWS as well, allowing on-prem hosts to learn that same route through ACI now from an external source this time. After a few minutes, Communication goes back to normal without us changing any IP addresses and totally transparent to the user. MSO is extending the VXlan network and the same policy from on-premises to AWS. Now let's take a look into Route 53 in order to check what happened to the DNS-based site. As you can see, we now have the on-prem web server VMs showing in red and the AWS-based instances in green, and we can still access both URLs successfully. If we now go to the Cloud APIC, we can verify that the same policies as defined on-prem were successfully instantiated now on AWS, and we are now communicating those instances using Cloud ACI instead. If we now take a look inside the AWS console, we can see both Linux and Windows web servers successfully migrated and running on AWS as expected, and that not only did we preserve the same IP as on-prem, but that the same policy was also applied through the microsegmented web server CPG. MSO automated all the necessary AWS native network configurations for us, such as security groups, amongst others, allowing us to reduce the learning curve when failing over or migrating to the cloud. Once servers are back on the main site, we can fail back if needed. Just remember to add the bridge domain subnet to the on-prem site from MSO. Notice we lost a single ping as part of the process.
Once the main site comes back online, and if we are using CloudEndure disaster recovery, we can prepare for failback, where CloudEndure will start the same process as before, in the case of failover, but in the opposite direction. It will synchronize the AWS instances data to the on-prem virtual machines, and operations can resume as usual. It is important to mention that the same process can also work for cloud-to-cloud disaster recovery.
Great, Herman. As a summary, when apps are DNS-based, subnet extension to the cloud is irrelevant for DR as a service and cloud migration purposes, and health checks, like the ones we provided in Route 53, can help you fail over even automatically. Cloud ACI and MSO extend the on-premises network and its security policies all the way to the cloud through its automated VXlan and MPBGP deployment, making failover transparent to the user and keeping operations centralized and consistent. The best part is that you're not sacrificing any cloud-native services nor suboptimal routing, as it sometimes happens with some proprietary solutions. It is also important to mention that if you are using tools like Terraform or Ansible to automate even further, MSO integrates seamlessly by providing you with a single provider or playbook that consolidates both on-prem and cloud networks. And last, CloudEndure can help you minimize downtime in a cost-effective way, and it can even be free of charge if you're migrating workloads to AWS.
I hope you've enjoyed the session today and that you've got some ideas of how to get started with the cloud and how to integrate it with existing on-premises environments.
This should allow you to provision your workloads faster anywhere your business takes you, minimizing risk and downtime. Thanks for watching.